Hello, I'm Greg. Welcome to my channel, Midnight Oil Software. This is part 1 in my new series on how to recreate Defender in Unity. So if you want to learn how to write a game from scratch in Unity, just grab your favorite beverage, pull up a chair, and follow along as I teach you how to write Defender in Unity. So it goes without saying, if you're going to create a game in Unity, you need to install Unity. And Unity is installed through something called the Unity Hub. You get the Unity Hub by going to unity.com/unity-hub. If you haven't already, you need to sign up for an account with Unity. And then after you create an account and logged in, you can scroll down and say download for Windows, or I suppose download for a Mac if you've got a Mac. After you have downloaded that, which will download a installer, unityhubsetup.exe, after you've run that installer and followed the prompts to install Unity Hub, you should end up with something like this, except if this is your first time using it, you won't have any projects. Now you need to go down to installs and actually install an editor. I'm going to be using 2021.3.13F1, which is the latest long-time support version of Unity that's available. I suggest using this version or something later. I do prefer to stick with the LTS versions. You could use a beta version if you want. I just think that these versions tend to be more stable and you run into less bugs and less issues. After you have installed that editor, which you would do by saying install editor, selecting the editor you want to install and clicking install, then you would go back to projects and say new project. And under here, we're going to create a new project and I'm going to call it Defender. And I want this to be a 2D URP project. URP is a universal render pipeline, and that's what we're going to be using for this project. And this installs a bunch of other packages and things that are specific to a 2D game, which is going to make it easier for us to go forward making this game without having to go to the package manager and pull in a bunch of different packages. After you've done this, make sure you're on 2D URP, you've given it a name, you have a location where you want to save the game to. In this case, I'm using the Unity Projects folder on my F drive, which is an SSD drive. I will click Create Project and let Unity do its thing, and this will take a few minutes. So I will pause the video and resume after this is all set up. Okay, so hopefully you've gotten your project created and it should have opened up into an empty project that looks something like this. If we take a look at what we've got here in the upper left-hand corner, assuming you have the default layout like I do, you've got your project hierarchy here. This is actually your scene hierarchy. We are currently in the sample scene. This scene was created automatically by Unity as part of that 2D URP project template. It's got a camera and a light source. On the right side, we have our inspector, where you can see the different values for the components that we have selected here in our hierarchy. So we have the camera selected. You can see it's got a transform. Every game object in Unity has a transform, which is used to control its position, rotation, and scale. And we will be covering a lot more of this stuff as we go through the tutorial. I'm just trying to give you a quick high-level overview here. Down in the left-hand corner, we've got our project hierarchy. This is basically the structure, the folder structure for our project. At the root level here, we have assets. Underneath of that, we've got our scenes, which has our sample scene. And there's a settings file that was created, or a settings folder that was created as part of that Unity 2D Universal URP 2D template. Yes, I can speak. This packages folder has packages that Unity pulled in as part of that template. We'll be using several of these, especially the 2D sprite stuff. I am using Rider as my editor. If you go under Editor, Preferences, and you go to External Tools, the external script editor I have selected as Rider. You can also use Visual Studio Code, or if you have a full version of Microsoft Visual Studio, you can use that. I prefer Rider. It has really good Unity integration, and I got a free 1-year license for it, so why not use it, right? I will try to call out when the keystrokes and things that I am using are different for a rider than they would be in Visual Studio, if you're following along with Visual Studio or Visual Studio Code. The other thing I did in my preferences while we're here, I just want to cover, is under colors, I changed my play mode tint to be this kind of a light blue teal color. If I was to click play, you'll see the whole workspace is tinted with that color. That's useful because anything that you change while in play mode, any scene changes you make are not applied. They're lost when you stop playing. I'll give a quick example of that. I'm just going to add a cube to our game. And if you look at it, the cube is at 0, 0, 0 with a rotation of 0, 0, 0 and a scale of 1. If I was to hit play and then grab that cube, and in the scene view, I'll grab it and I'll select our move tool. If I was to move it and maybe rotate it and scale it up a little bit and then stop playing, all those changes are lost. So it's useful to know when you're in play mode by having it tint like this. So I know, oh, I'm in play mode. I'm going to lose any changes I make. Let me exit play mode and make my changes so they'll be preserved. Now, while we're in the scene view, so you have your game view here, you have your scene view. This is where we do a lot of our design and layout and organizing the elements as they will appear in the game. Now, currently the game view is set to free aspect. I'm going to change that to be full HD, 1920 by 1080. I'm going to delete this cube here. I often like to take my game view and just dock it next to the scene view so I can see both of them at the same time. And under the game view, there's this menu here. It's either play focused or play maximized or play unfocused. If I say play maximized and I hit play, it will expand the game view to fill up the whole screen. Often when I'm doing development, I like to set it to play focused so I can still see the scene view while I'm playing. And then I can, of course, resize things to make the game view bigger if I want to while I'm playing. In the scene view, there's a number of controls. You can switch between 2D and orthographic view. So like, for instance, if I add my cube back, go to create a 3D object, cube. Right now I'm in 2D mode, which is great for laying out UI. But for game elements, you might want to switch to turning 2D off so I can actually rotate all around that object. I'm using the right mouse button to rotate around. I'm holding down the middle scroll wheel to just drag that back and forth. You can also zoom in and out using your middle scroll wheel. I'm going to put it back in the 2D mode for now since this is a 2D game. This area here is what would be visible in the game view based on our current resolution. So this is useful for how we're going to lay out our game elements so that we know how it will look when you're playing the game. And once again, I'll delete that temporary cube. Now I want to go back to our project structure under this assets folder. I'm going to collapse that packages folder. And I'm going to take this little slider here and I'm just going to slide it to the left until I just have the names of things. So if I come up to my assets folder, underneath of that we got scenes, we've got settings, and then there's this URP global settings file. I'm going to actually create a new folder under assets, and I'm going to call this, oh, by the way, so I'm right clicking, create folder. I'm going to call this underscore defender. And the reason I'm doing this is you notice this appears at the top of our project structure. So everything that we add that's specific for our Defender project is going to go in this folder, and it's going to be right at the top of our project. So you got packages down here at the bottom, you got settings down here. I'm actually going to drag our scenes into the Defender folder. So you can see that there. And I'm going to go in there, I'm going to rename the sample scene. I'm going to call it title scene. And it wants to reload because I'm currently in that scene. I'm going to hit Control S to save our scene. Now, if we go out to File, Build Settings, you can see right now, these are the scenes that we have in our build. If we add any new scenes, and we will be adding new scenes, we need to make sure we come in here and add them to this Scenes in Build. So if we build this game out, like we build out a desktop version, or maybe want to build out an iPhone version or an Android version, or maybe want to build out a WebGL version to host on itch.io or something, we want to make sure we include all the scenes from our game in the build. And I'm going to go back up to Edit, Project Settings. And these have settings that are specific to this project. And I'm going to click on Player. And we're going to give this a name. I'm going to go ahead and give it my name, Midnight Oil Software. The game is called Defender. It's version 1.0. And if we were going to be actually deploying this out and we wanted to include an icon for it, we would specify our icon here. The resolution that we want this to be for whatever platform. And you can see right now it's just got this Windows, Mac, and Linux. If we were building other platform types like iOS and Android and WebGL, you would see additional tabs here for those. You can also in here specify a splash image. There's other settings like the graphics quality and things. We're not going to touch on these mostly, but we are going to be using the new input manager. So currently it's set up to use the old input manager. We're going to actually be changing that, and I will show you how we do that when we get to actually handling user input. The next thing I want to do is I want to import some packages that I know I'm going to be using in this game. So let's jump back over to our web browser, and we'll close this Unity Hub. The next page I've got here is the Unity Asset Store, and I've done a search for DOTween because we're going to use the DOTween package. Now you'll need to be logged in. I'm already logged in here. So once you're logged in with your Unity account, search for DOTween, and then we're going to use this DOTween HotTween V2 package, which is free. There is a pro version of DOTween, but the free version does everything we need. So you would click this, and I already own it. But if you did not already own it, you would have to say add to my assets. And after you've added it to your assets, you would go back into Unity and go to Window, Package Manager. And right now it's looking at packages that are in our project most likely. We're going to change this drop down here to be My Assets. And I've got a lot of assets, so it's taken a while for it to populate that list. But over here, you got a little search box. You can scroll down and go through the different pages to try and find it. I'm just going to say DOTween in the search bar. And here you can see DOTween HotTween V2 comes up. Now, I've already downloaded it. If you've never downloaded it before, you're going to have a download button here. And so you'll click download, and after it downloads, you're going to want to click this import button. And then it will show you everything in that package that it's going to import. Let's just go ahead and import everything. So I'm just going to click, make sure all of these are checked, and I'm going to click import and let Unity pull these things in. Okay, so I had paused the video while it was importing, and after it finished, I've restarted recording. You should see this screen here, new version of DOTween imported, DOTween setup required. You want to click this button to open the DOTween utility panel. And we want to click this setup DOTween. And we're going to go ahead and let Unity think about this. It's got to recompile all the scripts that Unity pulled in as part of this DOTween package. So once again, I'll pause recording and I'll pick it back up when that's done. Okay, so it's finished compiling those scripts. So what we can do now is we can decide which modules from DOTween we want to pull in. And we're probably not going to use most of these, but I'm just going to go ahead and import all of them. I don't think the DOTween package is very big. It's not really going to impact your footprint that much. Let's just leave them all checked and click apply. And then we can go ahead and close this panel and close our package manager window. If we come down here to our project hierarchy and expand plugins, you see this Demi Giant. You open that up and you see there's a DOTween folder. I'm actually going to move this whole plugins folder under my Defender folder because I want this to be included in my GitHub repo when I commit this to source control, so that you can just grab it when you grab my repo and not have to worry about importing this package if you're just grabbing my code off of the asset store. And since it's a free asset, I don't have any compunction about doing that. The next thing I want to do is pull in some art assets. So under my assets folder, under Defender, I'm going to right click, create folder, and I'm going to call it art. Now, the project structure that I'm using, I think is great for a small game like Defender. I'm going to basically have folders for different types of files. So in this case, art files. So sprites can go in this art folder. Sounds can go in a sounds folder. Scripts can go in a scripts folder. Now this folder structure is not necessary. Unity will find these things no matter what folder I put them in. That doesn't matter. I'm just doing this as a way to organize the program so I know where to go to find things as I'm working on the game. So under art, I'm going to double click that. I actually have a number of assets that I have prepared for use in this game, and I'll show you where I got most of these assets. Some of them I edited myself, some of them I just grabbed from the internet, but I will have a zip file that I will share from my Dropbox folder that you can just grab that has all of these assets, and you can pull them in. You can also just grab this all off of my GitHub repo. I'll have a link to that repo in the description as well. But for now, I'm just going to go to my folder where I've got my assets, and I'm just going to drag in all of my art assets. And you see there's this BG Mountains, there are Defender sprites, some other folders, and I'll go through what I'm going to use these different images for. The BG Mountains one is basically a tileable image that I can use to display the mountains that will be displayed at the bottom of the screen. It's going to be a little bit fancier than the original Defender, which was just basically a little thin brown line that represented the tops of the mountains. I just really liked the look of this asset, and I thought it would add an extra bit of polish to the game, if you will. Now the Defender Sprites is a sprite sheet. I'm going to double click this to open it up in a graphics viewer. So you can see this is one big sprite sheet, and there's sprites for the different enemies, there's sprites for our ship, there is a sprite for the number of lives we have, for the number of smart bombs. So we're going to use several of these. We're not going to use all these letters and numbers and stuff. I'll go ahead and close that. There is a problem with this sprite. Right now you can see it's got a black background. We want this to be transparent. And even though if you look at it here, it says alpha is transparency, this is not transparent. What we can do is change this alpha source from input texture alpha to from grayscale and click apply, and this becomes transparent. I'm also going to reduce the size of this down. This is not a very high res image, so we can bump that way down. Even that's probably overkill. The other thing we want to change is we want the mesh type to be, well, actually the mesh type's fine. We want the sprite mode to be multiple, and then click apply again and go into the sprite editor, and we want to slice it, and we'll say automatic slice, and now we've got individual images. Let's click apply, close that, and if we look at this down here, you can see there's a bunch of individual images underneath Defender sprites, and I'm going to bump this slider back up again so you can see all the different images that are in there underneath of that Defender sprites sprite sheet. And we'll be able to access them just as individual images now, which is really, really nice. I'm also going to go back to this BG Mountains, and I'm going to change this to be full rect instead of tight. And then for the wrap mode, instead of clamp, I want repeat. And again, I'm going to lower this down to say 256 and click apply. And I can't even tell any difference in the quality of that image. And we're going to use that when we start working on our background. Some other images I've got in here. There's a title screen. I've already gone into a graphics editor and copied out this little logo here. We're not going to end up using this image anymore, so I'm just going to go ahead and delete that. You can see this image here. That's the logo I'm going to display on our title screen. And I'm going to do like I did for the sprite sheet. I'm going to make that transparent by changing this from grayscale. And again, this does not need to be that big. That's probably overkill, but we'll make it 512, click apply, and that's now a transparent image. Great. I'm going to probably not use this screen at all. This shows the example high score screen from the game, so I will delete that. I think I will use this screen here on my instruction screen that shows how many points you get for the various things that you can shoot. Shows you that this is your scanner. I'll keep that image around, but I will change the size of it. Maybe I'll make it 512. Click apply. That's probably fine. I don't think I need this image. So I actually used this image to pull into a graphics editor and basically just extract out this little area here, which is going to be our overlay panel. So let me delete this. And we'll take a look at that overlay panel, which is basically just going to show us our scanner area and then the bars on either side. And that will look nice to show us basically the area that our scanner can see compared to the entire size of the screen. And we'll also be displaying our score and our number of lives and smart bombs over in the upper left corner. And I'll go ahead and shrink this size down a little bit because it doesn't need to be that big. Well, maybe I'll do 512. Let's see. Well, you know what? This is going to actually extend to the whole screen. So maybe I'll just make it a 1024. That should be good. Okay, enough playing around with that. I'm going to show you where I got those images. If we go back into our browser, I'm going to close this Unity Asset Store tab. Up on itch.io, you can browse for different assets. And under backgrounds, I basically found this one, which is free platformer 16 by 16 background, which you can download. And it has a number of different tiles or layers, if you will, that can be used for a parallax effect background. We're not going to use parallax in this game, but I downloaded this zip file and then I pulled in those background mountains from it. And if you want to see how you find things like that, if you go to itch.io, scroll to the top, and you click browse, you hover over browse. So if I go away, that'll go away. If I hover over browse and click assets, you can click on free. And then I clicked on backgrounds. And then I just scrolled down until I found one I liked. And that was the one that I liked. The Defender sprites I got from a site. Some guy named Sean Riddle has a site with a bunch of assets from classic arcade games. He's got sprite sheets like this. And he's also got sound files. You can see here, he's got the start sound, the basically extra life sound, the sound it makes when an enemy lander picks up one of your men, the sound it makes when a ship materializes or when a swarmer is spawned. So I grabbed all of these sounds, and I also captured some sounds of my own to use in the game. And I'll go ahead and pull those sounds in now. So we'll close this, and I will go back into our project structure, and under Defender, I will right-click, create, folder, sounds, and I will open that up and go to my assets folder where I have all my sounds. And I will grab those sounds. I also grabbed a couple of sounds off freesound.org, which I will show you. Basically, the first two in the list here, you can search for these on freesound.org. So I'm going to use that for explosions, and that's my thrust sound for when the ship is thrusting. I didn't really find a good sound to use in those Sean Riddle pages, so I grabbed it off freesound.org. The other thing we're going to do is go back up to the Unity Asset Store, and there's an asset pack we're going to grab called Laser Weapons Sound Pack, which we're going to use for when the ships shoot. So I'm going to jump back into my browser. And on the Unity Asset Store, there's this guy, Daniel Sounds Good. I like that name. And if you look under his assets, you see there's this pack, Free Laser Weapon Sound Effects. So if you take that and you add it to your assets, we can go back into the Unity editor and add them to our game. So we'll switch back into Unity, assuming that you've done that. And we'll open up our package manager by going to Window, Package Manager. Make sure you're on My Assets, and you want to search for Laser Weapons. And here we have our free laser weapons. So you can download it, and then you can import it after you've downloaded it. Okay, now that that has downloaded, I could go ahead and download all of these sounds. In fact, I'm going to go ahead and do that. It's just a subset of the sounds from his paid pack. We're not going to use all these sounds, so we can go through and delete ones we don't use later. But I'm just going to go ahead and bring them all in so we can preview them if we want. So click Import and let Unity pull all of them into our sounds folder. Go ahead and close our package manager window. And it put them actually in another subfolder here. So I'm going to drag that into our sounds folder. So now it's part of our project. Now, the way I've got mine configured, if I click a sound, it automatically previews it. You can turn that setting off. So if I click on them, it won't automatically play anymore. But it's useful if you want to preview a sound. To have that turned on. If we go into our sounds laser weapon sound pack folder, expand the free folder, you can see all the sounds that we pulled in. So there's a few good ones in there, and we'll use some of those in our game. One thing I do like to do with all of the sound assets that I pull in, let me select them all. There are some settings that you can apply to the sounds. This quality doesn't need to be anywhere near 100. If I was to drop this down to say 10, and then say, I don't know, we need to change the compression mode, but if we could go ahead and apply this, I can pretty much guarantee we're not going to notice a difference in the quality of the sound. So what that will do is it will make those sounds take up less disk space, especially in the published build. So you can see the savings we're getting on the imported size after we apply these changes to our quality. All right, so that's a little bit of setup there. We've gotten our art, we've got our sounds. We can start working on setting up the layout for our title scene. the first thing I want to do is I'm going to look at our main camera here. So I select it. In fact, I'm going to take our hierarchy and I'm going to drag it in here next to our inspector. Okay, so we can see these things a little bit closer together. And I'm going to take our project and I'm going to dock it underneath of our hierarchy. And I'm just going to minimize the console down there a little bit. Give us a little bit more real estate for our scene and our game. And I'm going to actually reverse the orientation of the scene and game. Put the game over there and put the scene over here. And this is just personal preference. You can arrange your screens however you want. But let's take a look at our main camera here. And all of this stuff looks great. But under our background type, it's good that we have solid color, but I don't want that color. I want to use black. I think that would look better for our title screen. And then we're going to create a new empty game object. So one thing I want to do is I want to create a new empty game object and put these as children of it. So I'm going to say create empty. So the way I did that, I'll delete that so you can see. I right click, create empty. Another way to do that is I could have up here said assets, create, and then somewhere in that list there's probably empty game object. But I'm just going to right click there, create empty game object, and I'm going to rename this -- system -- and I'm going to drag the camera and this global light under there. So this lets me kind of hide the camera and the system, set the specific to the system under that little parent node. So the camera has a black solid color background. It's got an audio listener. That all looks good. Let's create another top level node here. So another empty game object. I'm going to call this one UI, which stands for user interface. And I'm going to create under there another empty game object, which I'm going to call title screen. In this title screen, we'll actually have a simple C# script attached to it. And so let's go ahead and create a scripts folder. So right click, create C# script. I will call it, oops, I actually created the script and I did not want to call it that. Let me delete that file. I want to create a folder. So I will right click, create folder, scripts. And I will double click to go in there. And I'm going to create another folder underneath of scripts called UI. And again, this is just the way I want to organize my project. There's nothing magic about these folder locations. I'm going to create a C# script in here. So I will say right click, create C# script, title screen. So we have a title screen script, and Unity likes to think about things when you add new scripts and recompile. So I am going to take this title screen game object, I'm going to click on it so you see it here in the inspector, and I'm going to drag our title screen script onto it. So this script is now a component of this game object. We'll get into editing that script later. I just wanted to go ahead and attach it there before I forgot. Let's add some more UI components to this game object. So under our title screen, which has a title script, I'm going to right click here and I'm going to create a UI canvas. And this is all fine. We want to put it on the UI layer, so I will change that. The canvas scaler, we do not want constant pixel size. We want this to scale with our screen size. Right now, our base resolution is 1920 by 1080. So we're going to change this to be scale with screen size and change our reference resolution to be 1920 by 1080. That way, if we resize our screen or play it on a different size device, the UI will scale appropriately to fit. The other thing I want to do is I want to add a canvas group. And the reason I want that is so I can fade this canvas in and out. And we'll use the canvas group to do that. You see it's got this alpha property. If this value went down to 0, it would be totally transparent. If it's up to 1, it's totally opaque. So now we want to add an image. Let me create a new empty game object. And I'm going to call it logo. And you see it gave it a rect transform because it lives underneath of this canvas. And I'm going to hit Alt and click this thing here to anchor it to the top of the screen. And I think I'm actually going to hit Alt Shift and click that so that it will stretch to fill. I'm not sure I want that or not. I'm going to undo that. We'll play with that later. We're going to add an image under this. So I'm going to say UI image, and we're going to drag in this Defender logo image. And right now you can see that's pretty small looking. So I'm going to scale it up about 10 wide and 3 high. And then I'm going to take this. Let's see how that looks. That looks pretty good. I'm actually going to bring this down a little bit, I think, because of the other elements I'm going to place on the screen. I don't want this flush against the top. It will still be anchored to the top center, but it's just not positioned flush up against there. We're actually going to zoom this in from script, so it will start out way in the distance and it will zoom in closer. We're going to want to add some text. So under our logo, I'm going to add a UI Text Mesh Pro. Now this is the first Text Mesh Pro object we've created, so it wants us to import this TMP Essentials. So we'll go ahead and click that, let it do its thing. And that's done. We can go ahead and collapse this panel. And we're going to want a font to put here. For now, let me just go ahead and enter the text for this field. We're just going to say Unity Tutorial. And we don't want this to wrap. I usually like to center everything, and then I turn off wrapping. And we're going to play with the font size and everything, but first we need to create a font for that. And we'll change the color too when we add it. But let's go and create a font. Under our Assets Defender folder, I thought I closed that panel. Under this Defender panel here, I'm going to right-click, Create, Folder, Fonts. I'm going to open that folder up, and I'm going to drag in a font asset, a free font asset. And this free asset is called Arcade. It's a true type font. And I'm going to show you where I got that font. If we go back into our browser, there's a site called 1001freefonts.com. I went up there and I just searched for Arcade, and this little doohickey came up. You can download that free for personal use. Make sure you check licenses whenever you're grabbing free things. So I will go back into Unity, and we are going to go up to Tools, or actually Windows, Text Mesh Pro, Font Asset Creator. And we're going to drag in this Arcade font and say Generate Font Alias. And there it is. And if we click Save As, it should put it in that fonts folder, and it did. So we have Arcade SDF. It is a true type Text Mesh Pro font. So if we come back up here to our text, I'm going to rename this to be Unity Tutorial. All right, so we come down here, we can drag that font into there. You can see it's already looking different. I want to scale that up though, so let's set the font size to be 72. And I'm going to change the color to be yellow. I think that looks pretty decent. I don't think I need to do anything else with that. I kind of like that. It looks pretty arcadey. Let's duplicate this field. I'm going to hold down Control and press D. And I'm going to rename that to buy. And I'm going to drag it down, change the text to buy. And then I will duplicate this, Control D. I will call this Midnight Oil Software. Change the text to be Midnight Oil Software. Drag it down. And I think that looks nice. We're going to duplicate this one more time. And we're going to call this, call it Press to Play. And I'm going to change the text on that to be Press Start to Play. This one I think I'm going to anchor to the bottom, but I'm going to move it up some. And I think I added a capital T in there that I didn't want. All right. So that's a pretty decent looking title screen. I'm going to hit Control S to save our scene. Now we're going to want to go and edit our C# script. So we go up to our title screen. You see we've got our script here, title screen. So I will double click on this to open it. I could also double click on it from down here, or I could even just right click on the component and say edit script. So there's a number of ways to get to the same thing. So it opens it up in Rider, which is the code editor that I'm using. If I was to expand Explorer over here, you can see our project structure. We don't want that open. I'm going to zoom in a little bit so you can see. So this is a typical Unity component C# script. So you'll see it derives from a class called MonoBehavior. If you're not familiar with C# and object-oriented programming, basically this is a base class that has functionality that's common to all the game objects in Unity. And so title screen inherits from MonoBehavior and inherits everything from that class, and then we can extend it to add whatever we want that's specific to title screen. Every game object in Unity derives from MonoBehavior. And here are a couple of functions that the Unity game engine will call for every game object that's loaded. It will call start, it will call update. You can see here that start's called before the first frame update. Update is called once per frame. So if you have a 60 frame per second frame rate, this will get called 60 times a second. This is what we call boilerplate code. If you've watched any Unity tutorials at all, almost every developer I've seen that writes tutorials will go in and immediately delete all of this boilerplate code every single time, and then they'll start writing their script. Now, I'm going to show you a little trick that will save us a bunch of time. So on your hard disk in the program files folder, there is a folder for every version of Unity that you've installed. So in this case, we're using 2021.3.13.f1. So there is a folder on the hard drive which has a script template that it will use whenever you create a new script. So like if I say save as, you can see this is under Program Files, 2021.3.13.f1, Editor, Data, Resources, Script Templates, and I'm editing this script, new behavior script.cs.text. Now it's important to note that I am running Notepad or whatever editor I'm using, I'm running it as administrator because you typically don't have write permissions on files under the Program Files folder. So I had to open this up as administrator. I did not mean to collapse all my windows. Let me go back into my Notepad editor. What I'm going to do is I'm going to delete all this boilerplate code from the template. So Unity is using this template to decide what to put in every new C# script that we create for MonoBehaviors. That's all I want when I create a new MonoBehavior. So I'm going to save that. And I'm going to delete I'm going to remove this component. I'm going to delete this script. And I'm going to recreate it. So I would say right click, create, C# script, title, screen, wait for Unity to recompile. And you can see already in the preview window, it's missing all that boilerplate code. So it created that new script without all that fluff that I'm going to delete anyway. I will drag the script up to our title screen, and I will double click on it to open it in the editor. So what do we want to do in that title screen script? The first thing we're going to want to do in this script is add what we call serialized fields. These are properties or fields on this class that we can set in the inspector, in the Unity inspector when we're basically designing the game. So we're going to put an attribute here. You declare an attribute by using brackets, square brackets. And we will use serialized field, and I'm letting Unity auto-complete that. And we're going to create a canvas group field, and we're going to call it canvas group. And we're going to use this to fade the page in and out, or really just in. We're also going to add a field for our logo that we're going to want to scale in. And we're going to scale it by its transform. So we're going to add another serialized field. We're going to call this transform logo. And finally, I'm just going to add a game object for the text that we're going to toggle on and off to say press start to play, because I don't want to show that prompt until we've completely zoomed in our logo and faded in the screen. So add another serialized field, game object, I'll call it press start to play. And I'm going to have a Boolean here that says whether or not start was pressed. So this is a variable. A Boolean is a variable that's either true or false. By default, it will be false until we set it to true. And we're going to use this to determine if we should leave this scene and go to the main scene. Now, we're going to do some things when this screen is first enabled. So I'm going to add an on enable. So we already saw start and update. This is another function that gets called by Unity. If we hover over this, you see this function is called when the object becomes enabled and active. So the first thing I want to do is make sure that we're not showing that press start to play. So I'm going to say press start to play set active false. So we're hiding it. We're not going to be showing that until we've fully zoomed in and faded in. The other thing we want to do is we want to make sure our canvas group is completely faded out. So I'm going to say canvas group dot alpha, that was that property that we saw in the inspector, equals 0. And now we're going to use that new library, that DOTween library that we imported into the game to fade it in over 3 seconds. So I'm going to say canvas group dot do fade, and you can see it's saying using dg.tweening. And when I select this, we're going to see it's going to add a using statement up here. Well, I actually have to tell it to add the using statement. Or maybe I'll just type it in. Using dg.tweening. And you can see that turns green. It's happy now. So we're going to say do fade. And if I hover over this, you can get a description of the parameters that this guy wants to take. So this is what's called an extension method. So it's basically extending the canvas that we're operating on, or the canvas group that we're operating on. So you can see the first parameter in do fade is canvas group, but it's a this parameter. I actually don't pass that in because it's operating against this right here. We're going to give it an in value and a duration. So our in value is going to be 1, which is fully faded in, and the duration is going to be 3 seconds. So this will start a tween operation that will tween or animate from fully faded out to fully faded in over a period of 3 seconds. The other thing we want to do is we want to scale in or zoom in our logo. So we're going to take our logo, which is a transform, which remember, a transform is used to control an object's size, position, and rotation. We're only going to mess with its size or its scale. So we're going to take its local scale. We're going to set it to vector 3.0. This is just a shortcut for vector 3, 0, 0, 0. So the X, Y, and Z are all 3, 0. It's just a constant that we can use. So we don't have to say new vector 3.000. All right. The next thing we want to do is enable, well, we want to do a do scale. So we're going to, the same way we did a do fade, we're going to do a do scale, but this time it's going to be on the transform. So we'll say do scale. And we've already got our tweening library, so I did not have to add the using statement again. So the parameters for do scale, it wants the target, which is the transform, which is underscore logo. But then it wants the end value, which we're going to scale it up to about 3 times its normal size. And then the end value, or the duration, is also going to be 3 seconds. So we're going to say vector 3.1 for our first parameter. So that's going to be fully zoomed in over a period of 3 seconds. So vector 3.1 is a constant that's 1, 1, 1. All right, vector 3, 1, 1, 1. So X, Y, and Z are all 1. Good. The other thing we're going to want to do is we're going to enable that game object that shows our enable press key to play. So I'm going to add a void method here. A void method is a method that does not return anything. So it's just going to execute and be done. So I'm going to say press start to play. And what we're going to do is we're going to make sure to set the start pressed is false. And we're going to say press start to play dot set active true. And we're going to use invoke, which is a way to delay execution of a function. So we're not going to execute this until we've completely faded in. And the way we're going to do that is we're going to say invoke name of, and we'll give it the name of that, enable start press to play. And then the parameter for the duration or the delay will be 3 seconds. So invokes the method in time seconds. Okay, so that should get our screen to display, fade in, and zoom in the logo, and then after 3 seconds, display the press start to play. Now, we currently are not getting any user input, so we have no way of knowing if we pressed start, but at least let's see if we got that part working where it's displaying the UI. So we'll go back into Unity. Let it recompile the changes that we made to the scripts. And on our title screen, now that we've added serialized fields to our script, you see here in the inspector, there's 3 fields here. There's canvas group, there's logo, and there's press start to play. So canvas group, I'm just going to drag in our canvas because canvas group is a component on that canvas. For logo, I'm going to drag in the logo. So that's the transform of this logo. And this guy, his transform, this is not to be confused with his rect transform. He's got a scale of 1, 1, 1, whereas the image, remember we scaled 10, 3, 1. But what we're going to do is scale this from 0 up to 1. So to go from completely zoomed out to this scale right here. Going back to our title screen, the press start to play element is that one. So it should, when we start, be faded out. This should be out in the distance. We should not see this prompt. and then it should fade in, and this should zoom in, and then we should see this prompt appear. I'm going to say play maximized, save my scene by hitting Control S, and I'm going to hit play. We got our tint mode to know we're in play mode. And there it faded in, start to play showed up, and that all looked good. Now I am going to show you one way we can clean that up just a little bit. I did want to show you invoke just so I could introduce the concept of invoke and delayed execution to you, but we can actually do this a lot better. We can wait until we're done scaling our logo by saying, I'm going to put this on a new line, dot on with a capital O, complete, enable, press start to play. And so this will wait until this completes, and then it will call this function. So if I go back into Unity, let it build, and hit play, there we go. I did want to demonstrate how the canvas group works. So if I look at that and I go down to our canvas group and I take our alpha and I drag it down, you can see how it fades in and out. So that's how that works. So we want to go ahead and implement the input system so that we can press start and go to the next scene. And for this tutorial, I put a poll up on my channel and asked if people would prefer the old input system or the new input system. And it wasn't a decisive majority, but it does seem like there were a few people that would prefer the new input system. And since I haven't covered that in a tutorial before, I figured I'd go ahead and introduce it in this one. I'm going to encapsulate the input behind a component I'm going to extract an interface from. There's several reasons I want to do this, but one reason is to make it testable. So if I decide to write unit tests for this project, I can mock the input. So I'm not relying on actual real input to test my code. But I'm going to start off by creating a new empty game object. So right click, create empty, and I'm going to call this user input. And I'm going to add to that player input. Now player input's not available. And that's because we got to go tell Unity that we're using the new Unity input system. So we actually have to install a package for this. It's a built-in Unity package. So we'll go Window, Package Manager, switch to Unity Registry, and type in input. And you see this input system, a new input system which can be used as a more extensible and customizable alternative to Unity's classic input system and Unity Engine.input. So it was last updated November 3rd, version 1.4.4. We will click install. So after a couple minutes, Unity pops up this dialog. The project is using the new input system package, but the native platform backends for the new input system are not enabled in the player settings. This means that no input from native devices will come through. Do you want to enable the backends? Doing so will restart the editor. We want to click yes here. And I'll go ahead and save the changes to our game before it restarts. And finally, Unity has restarted and come back up to this screen. Now, if we go to our user input and say add component, and we type input, you can see player input. We want to add that component to our game object here. And we need to actually create a new action access, input action asset. So there's a default one, but we want to click create actions. And I'm actually going to create a new folder for this. So I'm going to go into our Defender folder. I'm going to right click, create folder, and I'm going to call it input system. Double click to go in there. And let's go back to our user input component, click create actions. And we are going to go into that Defender input system folder, and we'll let it use the name Defender input actions. And click save. And that opens up this dialog. Now by default, it gives us two action maps, a player action map and a UI action map. And we're not going to worry about the UI one, but on the player one, you can see there are move actions, look actions, and fire actions. Underneath of move, we've got a gamepad control, so using the left stick. And then we've got WASD keyboard controls for up, down, left, right. It also uses the arrow keys, as you can see here. And there's an XR controller. And this gives us a 2D vector. So it's giving us an X and Y value for left, right, up, down. So this is only active in the gamepad schema. And if we look at these, they're only active in the keyboard and mouse schema. And if you look at this text here, it says that we could uncheck those and they would be active in every schema. But we're going to go ahead and leave those only applicable to keyboard, mouse, and only applicable to gamepad. And then I'm going to get rid of the XR. I'm going to say delete. And we don't have a joystick, so I'm going to say delete. And I don't have any look actions, so I'm going to delete that. Now let's go look at fire. Fire's using the right trigger, that's good. Or the left mouse button. I guess that's fine, I don't really care about that. I'm going to delete the touch screen. I'm going to delete the joystick, and I'm going to delete the XR controller. I am going to add another control for fire though. So one of the things about Defender that I think was part of the appeal of Defender, and especially from some of the comments I've seen, is how difficult it was because of the controls, because you had so many different controls. There was a joystick that was only used for vertical movement, up and down, and then there was a thrust button, but then there was a reverse button that would change direction. So instead of using your stick to go left, right, up, down, you only used your stick to go up and down, and then you would thrust, and then you'd have to push a whole nother button to change directions. And then there's a fire button, and then there's a smart bomb button, and there's a hyperspace button. So for our game, to make this as close to the original as possible, I could just use the left stick and use both axes on the vector 2 that this guy is giving us for left, right, up, down, but I'm going to ignore the left, right axis on this stick, and I'm also going to get rid of the left and right keyboard and mouse, or the keyboard controls here, and I'm only going to use the up, down for movement, and I'm going to add a thrust, and I'm going to change fire to use the M key. And so we'll use the N key for thrust and M for fire, and then I'm going to use the comma key to change directions. So you'll have your three fingers there on N, M, and comma for thrust, fire, and change directions. And then you can use W and S for up and down. And I'm also going to use a gamepad controller as another option. So let's go in here and look at left, and I will delete that. Left, I will delete that. Right, I will delete that.
It's decaf.
Right, I will delete that. And I don't really care about this left mouse button. I'll leave it for now. And we're going to want to add a new action, and it's going to be thrust. So I will call this thrust. And then we go to our bindings. And so we're going to want a keyboard control. You can actually come into this path control here. I could click keyboard. I could come here and I could go down the keyboard and I could, search for the key. But there's another way to do this. I can just drop this down and say listen, and I can click the N key. And now we have the N key mapped to thrust for the keyboard and mouse. Let me go back up here and to fire. I want to add another binding under fire. And I'm going to select the path, say listen, and I'm going to hit M. And that's only valid for keyboard and mouse. Okay, so we've got thrust with the keyboard, but we need to add thrust for the gamepad. So I will come under thrust here and drop this down and say add binding. And then under binding, I will go into path and I will say listen, and I'm going to use the right stick on my gamepad. And I want right stick right. So I'm going to pick that, and that's only valid for gamepad. So now we've got thrust, we've got fire, we got up and down. The next thing we want to do is add flip direction. So we'll add a new action. I will call it flip direction. We'll go to our bindings, click on path and listen, and we're going to use the comma key. And then we're going to want to add another binding. I'll go to path and I will click listen, and I'm going to actually push down on the right stick. So we have right stick press gamepad. So that's going to be gamepad, that's going to be keyboard and mouse. So we have flip direction. I want to add the start button because we're going to actually use that to close this menu. So we'll add action, call it start, go to binding. I'm actually going to allow it to use any key from the keyboard. And then we'll add a new binding. Go over here and I'm going to click the start button. I did not click listen apparently. Click listen and start. And that will be a gamepad. So gamepad, keyboard and mouse. All right, so we now have controls for our Defender input actions for move, fire, thrust, flip direction, and start. Let's go ahead and click Save Asset, and autosave is now saved. And you can see here in our input system folder, we have this Defender input actions. Now, if we look at this over here, you can see our default scheme is any. So it's going to look and try and detect what input controls are available on this system. And then auto switch is true. So it will switch between gamepad or keyboard and mouse based on what buttons are pressed on which device. And our default map is player, which is this action map here. So there is the other UI action map, which we haven't looked at, and I'm not even sure I'm going to use that. We're just going to worry about this player action map. So we have a user input with a player input control using our Defender input actions. So now we need to add a script to this. So let's go into our scripts folder, and I'm going to create a new folder. Right click, create folder, and I'm going to call this input system. I'll go into that folder and I'm going to create a new C# script. And I'm going to call it user input. So that will match the name of our game object up here. Let Unity recompile that script. And I'm going to drag that script onto our user input and double click that to open it up in the editor. And I will zoom in here. So I'm going to make this a singleton. A singleton is essentially an object that there will only ever be one instance of it at a time. And we're going to automatically load this input component when the game starts, and we're only going to have that one copy for the rest of the game. And so I'm going to create in here a static field called user input, of type user input, and I'm going to call it instance. And then in our awake method, I'm going to check to see if instance is null. Actually, I'm going to check to see if it's not null. So if instance isn't null and instance is not this, so it's not the component that we're currently in now, then we're going to destroy our game object. So this is apparently a new game object that somehow got instantiated after the first one was created. And I'm going to return. Otherwise, I'm going to set instance to be this, and I'm going to call don't destroy on load on the game object. This will prevent this game object from being destroyed when we change scenes. So now we have a singleton instance of our user input. Now we want to define some things that we're going to do with that input that we get from our parent component, which is, of course, that defender player input component. So first I'm going to add some events. And before I do that, I'm going to go up here and I'm going to add a using statement. I'm going to add the Unity engine .input system. So we're using the new input system. And let's declare some events. I'm going to have an event. It's going to fire an action with an input value as a parameter. And I'm going to call this onMoveReceived. So I want to go back to our Unity editor. And I want to take a look again at our input actions. Actually, I want to take a look at this player input component. And down here, you can see that the behavior is set to send messages. So what's going to happen if we go and open this guy up again? You see we've got this thing called move. We have an action called move. Well, when any of these move actions are performed, when any of these bound inputs are pressed, it's going to send a message to our class, and it's going to be on move. And this will be on fire, on thrust, on flip direction, on start. So we go back into our script. I've defined an event called onMoveReceived. And so what we can do down here is we can add a method, a void method called onMove. This is the function that's going to be called by the input system. It's going to pass in an input value, and that's actually going to be a vector 2 when we get the value out of it. We're not going to worry about that right now. What we're going to do is I'm going to do a debug log, and I'm going to say, and this little $sign says I'm going to use string interpolation. This will let me put variable values in this string. So I'm going to say onMove, and I'm going to put in curly braces value. So it's going to take the value of this variable value and it's going to display it in this log statement. And then the other thing I'm going to do is I'm going to say onMoveReceived, and I'm going to use a null interpolator. So if it's not null, then I'm going to call invoke, and I'm going to pass in value. So now other classes can subscribe to our onMoveReceived event, and if anybody has subscribed to it, I can notify them that onMove was pressed by invoking this event. And this needs to be public, and it is. I'm going to move this line up to the top of the screen. I'm going to hold down Control, Alt, Shift, and this may be different in Visual Studio, but that just let me use the arrow keys to just move that line right up to the top of the script. I want all my public events or public properties or fields at the top of the file so I can quickly look at this file and see what I can access from other classes. Okay, so we're handling onMove, and I want to give this a test. So I'm back in the Unity editor. Right now the user input is already in our scene, and it's got our input actions. If I run and I hit any of the move keys, either the WS key or the thrust, well, not the thrust key, but the WS key or the left stick on my gamepad, I should see a log statement in the console that says on move and then the value that was passed into it. So I hit Control S to save my scene. I don't want this to be maximized because I want to be able to see what's going on in here. I will hit play. And I'm going to hit the W key. And you can see I've gotten 4 move events. As I'm hitting the W and S keys, I'm getting events. And I'm going to use the left stick now. Up, down, and I can see I'm getting more events. So we know the on move event is working correctly and is being handled by our class. So let's go back into that script and let's add all the rest of the events we're going to need. So let's add one for on thrust received, and we'll add one, and this one's not going to take a parameter, it's just on or off, so it's going to be on flip direction pressed. Let's add another one, and it's going to be on fire pressed, on start pressed, and I think I'm just going to leave it at that for now. So we've got on move. Let's go ahead and do on thrust. And we're going to say debug log on thrust value and on thrust received non-interpolate invoke value. Okay. I think another thing I want to do though is I actually want to store these values in here in case we want to access them from outside the class without actually receiving an event. I just want to be able to look at this and I want to see, are we thrusting? What's our value of move input? What's our value of thrust input, and so forth. So I'm going to add some variables here under the events. I'm going to have a bool is thrusting, and I'm going to use what's called an expression body method. This is basically shorthand for adding a getter and then returning something. I'm just getting rid of all these extra lines of code, and I'm just saying all I want to do is return thrust input dot y is greater than 0, and then I will greater than 0, and then I want to create this variable. So in Writer, I just hold down Alt and hit Enter, and I say create field, and here I've got this private variable thrust input, but this needs to be a vector 2. So this did not know what kind of variable I wanted. All right, so if thrust input dot y is greater than 0, we're pressing the, is it y? I think it's y on the gamepad. I might have to revisit that, but I think that's right. All right, I want to add another one here. A public vector 2 move input, and it's going to be another expression body method, and I'm going to give it a move input variable. I'm going to create a vector 2 move input, and so down here I'm going to set move input equals value dot get, is it vector 2? Is that right? Yeah, I believe that is right. And then down here, I will say thrust input equals value dot get vector2. All right. I want some more variables here. I want up pressed and I want down pressed. So these are private fields. These are public. So I want public. Actually, I want to expose thrust input too. So I'm going to say vector2 thrust input expression body method thrust input. I want a public bool up bool, not boo. Up pressed expression body method will be move input dot y is greater than 0. I really think this needs to be. I don't think I want this. Or if I do, I want that to be x. Yeah, that needs to be x. And then for the down pressed, it will be move input dot y is less than 0. And the more I think about it, I don't even want this at all, because we don't have any horizontal movement input coming from our input system. We only have vertical input coming, and we have an event for when thrust is pressed. So it would not make sense to have a field in here to expose a thrust value like that. So let's handle the rest of the events. Get rid of this. We're going to want to handle the on flip direction. So we'll say on flip direction. This will be an expression body method that's just going to say on flip direction pressed. We'll use a null interpolator and call invoke. We want to do the same thing for on fire. We want to do the same thing for on start. So we're basically just passing these events on to anybody that might want to subscribe to the events. We're adding a layer of abstraction between our input system and anybody that's going to consume the input system. Do I have an on submit press? I do not. Did not want to create a class. I want to say public event action on submit pressed. There. Okay, I think that is good for our user input class, but we want to extract an interface from this, and we want to actually use that interface, and then later we can mock input for unit test. So I'm going to right click on this. I'm going to go to refactor, extract interface. And what do I want to extract? I want to extract all these events. I want to extract move input, up pressed, down pressed. I think that's it. So I'm going to say next. And it has extracted an interface called UserInput. And you can see it's basically just defining the contract to our class, and now our class implements that interface. So I'm going to take this, I'm going to hit Alt Enter, I'm going to say move to UserInput.cs. So now it's in its own file. Nice. I'm going to go back to my source file though and go down to the bottom. And these guys where I'm just doing expression body methods is probably fine, but I want to log what I'm getting just to make sure it's working. Well, that's something I could do if I'm debugging in the future. If I find that some input doesn't seem to be working, I can come back in here, and Writer may actually suggest that I change this to a statement body. So instead of being an expression body method, it would break it out into a statement body like this. But I'm going to leave it like this for now, unless I run into problems and I want to come in and debug it. So jump back into the Unity editor, let Unity compile scripts. So here in our scripts input system folder, you see I've got two files now, UserInput and iUserInput. So I want to go into our title screen where we've got our title screen script. And I'm going to double click that to open up that script. And what I'm going to do is I'm going to get the iUserInput interface. So I'm going to declare a variable here called iUserInput, and I'm going to call it UserInput. And we need an await method. Did I type that wrong? There we go. So I'm going to add an await method. And what I'm going to do in here is I'm going to say that UserInput is equals, I'm going to use a function called find object of type. And I want this one with the angle brackets. And I'm going to get the user input. And since that implements iUserInput, I can assign it to that just fine. Now, we don't want to actually try and access that from inside awake, because it's possible that that user input component has not been instantiated yet, or hasn't been activated yet. So I want to actually handle in the onEnable method where we're doing all this other stuff like scaling and fading. I want to subscribe to that iUserInput on start pressed event. I'm actually going to do that before I start the scale operation here. So I'm going to say underscore UserInput dot on start pressed. I'm going to subscribe to the event, and the syntax for that is to say plus equals, and then I want to give it a function name. I'm going to call this handle on start, which doesn't exist. So I'm going to right click on this, hit Alt Enter, create method handle on start, and now I've got this function here, handle on start. And if we subscribe to an event and on enable, it's always best practice to add an on disable, and we want to unsubscribe from that event. So I'm just going to copy this line here, paste it over this throw that we don't want, and now instead of subscribing to the event, I'm going to unsubscribe. That way, if for whatever reason, when this screen is disabled, I'm no longer listening for those events. All right, so in handle on start, I've got this variable up here called start pressed. I thought I was setting that to false somewhere. I'll go ahead and, oh, it's here. All right, so in handle on start, all I'm going to do is say start pressed equals true. And we're going to add an update method. So in update, if press the key dot active self, so we've displayed the message, we've displayed the prompt saying press start to play, and start pressed is true, then we're going to call our scene manager, and we need to add using for that, so it added Unity-engine.scene management. Ryder did that for me automatically. If you're using Visual Studio, you'd either have to do like a right click on it and say import missing using statements, or type it in manually. So scene manager dot load scene main. Now we don't have a main scene yet, and Ryder is complaining about that. There's no scene with that name in the project. So you know what? Let's go create that so we can test this. Go back out into Unity. We will click our scenes folder. I'm going to say create scene, and I'm going to call it main. And it's very important that this is named the same as what we're trying to load from that title scene. And right now our main scene just has a camera and nothing else. So let's go back into our title scene and open that script. I just want to look and see if the warning went away. And it's not in our build settings. So you remember I told you in the beginning, if you look under File, Build Settings, whenever we add a new scene, we need to add it to our build settings. So I'm going to go up into our Scenes folder and just drag main into there. Another option is I could have opened that scene and then click this Add Open Scenes button. All right, now if we go back into our title screen script, the warning is gone, so it recognizes that there is indeed a scene called main in our build settings. Clean that up a little bit, jump back into Unity, hit play, and see what happens when I click start. I clicked start on the gamepad and it went to the main scene. I'm going to try it again, and I believe I set up in our user input that any key would work for start. So go to our input system. Let's look at start. Yeah, so any key. So we're in our title scene. I will hit play. When I see that prompt, I'm just going to hit space. And it works. I think before we leave our title scene screen, or our title screen scene, I want to add a start sound to it. So I'm going to go to our title scene object here. I'm going to add a component. I'm going to add an audio source. And we're going to give it an audio clip. And the clip I want to use is, I want one that's going to be the game load sound. So I'll go into our sounds folder, and here's one I called game load. So all I'm going to do is go back to our title scene and to this audio source, and where we see this audio clip, I'm going to drag game load into there. It's already set to play on awake. I'm not really sure about the volume level here. We'll leave it all the way up and just see if that sounds good. If I hit play, we should hear that sound. And we do. But before we go to our main screen, there is one thing I want to do first. I want to create a prefab from this user input. Now, we haven't talked about prefabs really yet. But a prefab is basically a prefabricated object that we can just instantiate into our scene, and we can reuse it. So if we want to have, I could create a prefab for the player ship, and then every time I want to spawn a player ship, I just instantiate an instance of that prefab. So what we're going to do in this case is create a prefab of this user input, and I'm going to write a Bootstrapper script that when the game first loads will load this prefab and instantiate an instance of it and call don't destroy unload on it so it won't go away. So I'm going to actually create a new folder in here, and I'm going to call it resources. So I'm in Defender. I will right click here, create folder, resources. Now, this is one of the rare cases where Unity actually cares about the name of the folder. Another case would be editors, if you want to create custom editors. But in this case, we want to load a resource at runtime, and it's going to look for it in a resources folder. So we'll double click in there. We will grab our user input and drag it into that folder. And now I'm going to delete it from here, because we don't want to have to manually add that to every scene in our game. We just want it to always appear instantly when the game is run. So now that we have that prefab, we need to go into our scripts folder, and I'm going to create a new folder, and I'm going to call it managers. So this really is sort of a manager type script. And I'm going to create a new C# script, and I'm going to call it Bootstrapper. And I will double click that. And this is not going to be attached to any game component. Okay, it's going to have an attribute to tell it when to run. So I'm going to create a function in here. It's going to be a static method. So public static void initialize. It doesn't really matter what the name is. What matters is the attribute I'm going to put on it. And a static method is one that you can run without having an instance of the class. So instead of having to instantiate a Bootstrapper and then calling Bootstrapper, that instance dot initialized, I can just say Bootstrapper dot initialize. So Bootstrapper being the type, and this is a static method on that type. So I am going to actually up here, I'm going to create an attribute called runtime initialize on load method. So as you can tell by the name, when this is running, it's going to initialize, it's going to call this method on load. And then we give it a parameter to tell it when we want it to run. So it's going to be runtime initialize load type, and we want subsystem registration. So creation of runtime class used when scenes are loaded. And so this determines when it's going to load. And in this case, subsystem registration. So now in here, I want to get our prefab. So user input prefab, we're getting it from resources. So this is why that folder name was important. And we're going to say load, and I'm going to give it the name user input. Now it added a weird using statement up here, which is not what we want. It should just be getting this from Unity Engine. It's because I left an S off of here. So it should be resources.load user input. So it's going to look in our resources folder, wherever that happens to be. In this case, it's under our underscore defender folder. And it's going to look for a prefab called user input. If that's not null, so we found it, then we are going to instantiate an instance of that. So we say user or var user input equals game object dot instantiate user input prefab. And Unity's telling me I don't really need this, it's redundant. And I want to set the name, because by default the name it's going to give it is going to be user input and then in parentheses clone. What I want is something I can really see in the inspector that's going to stand out. So I'm going to call it user input.name. I'm going to call it dash 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 user input dash dash dash. And then I'm going to call don't destroy unload on the game object itself. So now this should find, load the prefab, instantiate an instance of it, set its name, and then call don't destroy unload. If I go run the game now, we should see our user input appear automatically. It's going to be under a node called don't destroy unload. So right now there's no user input in our scene. Let's click play. So you see don't destroy unload. If I expand that, you see user input. You also see our DOTween and then something Unity added called debug updater. So under our user input, you see I've got our input actions. So that is now available no matter what scene we're in, we have access to our user input. And I think we're about ready to get into the fun part and start working on the actual main scene. I want to move this event system up under system just to hide it a little bit. That looks good. Let's go into our scenes folder and double click main. So right now we've got a main camera. Let's just change his background type from skybox to solid color and make that black. That looks good. And I think I'm going to put that under system as well. So I will create an empty object and call it system. And I'll just drag the camera under there. Okay, and let's see if we can't add our ground, the mountain. So you remember in our art, I've got this BG Mountains image. And so what we're going to want to do is drag that into our scene. So I'm going to create an empty game object here and call it background. And I'm going to drag in that background mountains image. And we're going to change it from simple to tiled. We're going to set its width to be 100. And we're going to move it down till it's just touching the bottom of the screen. Okay, I think that looks good. The way we're going to handle movement in this game is we're not really going to move the player's ship left and right. We're going to scroll the background to make it look like the ship's moving left and right. And we're going to put all the other objects that are in the scene, the enemies, the people that we're trying to protect, and that sort of thing, the projectiles, they're going to be under a root object that will also move left or right based on whether the ship is thrusting left or thrusting right. So we'll try and get that working in this video just so you can see how we're going to handle that movement. And then maybe in the next video we can go add some of the UI components, the overlay, the overview area on the top of the screen and that sort of thing. But for now, I just want to get the PlayerShip on there. I want to wire in the movement and I want to be able to see it scrolling left and right. So let's create an empty game object. And I'm going to call this player. Actually, I'm not going to do that. I'm going to delete that and I'm going to drag in from our Defender sprites this guy here. And I'm going to rename this PlayerShip. And that's going to be our PlayerShip. And there he is in the middle of the screen. And I'm going to scale him up a little bit. Say 1.5, 1.25. I think that looks a little bit better. I think all of this stuff is fine. One thing I do think I want to do is eventually I'm going to put him on his own layer, but for now I'm just going to leave him like that, but I will change his order layer in 1 to make sure he displays in front of the mountains. So that should be good. And let's add a component to him. I'm going to call it engine thrust. So right click, create empty, engine thrust. And I'm going to add an audio source to that. And for its audio clip, we'll go down to sounds. And we're going to add that. So that will be our thrust. We don't want it to play on awake, but we do want it to loop. And I'm going to turn the volume down to about half, give or take. All right, so now when this is active, it will thrust. You'll hear that thrust sound. So we can test that after we get the controls wired up. I'm also going to want to add some particles to the engine thrust. So right click, create empty. I'm going to call it particles. And I'm going to add a component, particle system. Okay, so we want the duration to be 1. We do want it to loop, no start delay. The lifetime on these particles is going to be much shorter than that. The start speed is probably fine. I'm actually going to make that a random between 2 values. Say 5 and 2. And I think that's good. Let's see, like start size, I'm going to make that 0.44. Actually, I'm going to make that random between 2 constants, 0.44 and 0.5. That's just a tiny little difference. Don't need to worry about rotation. The start color, I'm going to make them red to start. And they look kind of weird right now because there's no material assigned to them. No gravity modifier. Simulation space will change to world. We want those particles to be emitted and then exist in a world not local to the ship. Simulation speed, probably 1 is fine. That's fine. Scaling mode is going to be shape. And we do want it to play on awake. We want the velocity mode to be transform. That's probably fine. That's probably fine. Let's go look at the emission settings. Let's emit 42. Let's look at the shape. So cone's good, but we want the angle to be 1. Radius should be tiny, 0.01. Radius thickness 1 is probably fine. Arc 360 is probably fine. Mode random, speed 0, length, that's probably fine. I think all of that's fine. Let's go take a look at the color over lifetime. I think all I really want to do there is fade it out. So we'll turn that on, go into here. So up here, alpha is all the way up. Down here, alpha is all the way off. So it will fade out. That's good. And we need to look at the size over lifetime. And this is pretty much the opposite of what we want. We want it to go from 1 down to about 0.4. That's probably about pretty good right there. All right, so they'll shrink and they'll fade out over time. Let's go and look at the renderer now. So billboard's good. This is good. This is where we need a particle. I'm going to see if we have default particle. That should work. That looks good. That looks good. I think everything else looks good. We just need to move it. And I don't know why it's not looping, because I turned looping off. All right, let's just move its position. I think that looks pretty good. It looks pretty good over here. I'm going to leave it like that for now. So now when we hit play, we should hear the thrust sound because the thrust is currently turned on, and we should see the particles. And I'm not hearing the thrust sounds. Play on awake is not true. That's why. We're going to want to turn that off after this test. All right. So I think that looks pretty good. We got some particle effects behind the ship, and we have a thrust sound that will be activated when we actually thrust. So while we're working on our player ship, let's go add a couple more components here. We'll collapse our sprite renderer. We're going to add a rigid body 2D. And we're going to turn off gravity. then we're going to add a box collider 2D. And let's edit this guy and let's shrink him down. It doesn't need to be that big. Oops. Grab that. Pull that in. Pull that in. I think that's probably good enough for a collider on our ship. And we're going to have to start writing the script. So in our scripts folder, I will right click, create C# script. And we're going to call this PlayerShip. Let Unity think about that. And I'm going to drag that script on there and then double click to open it up in the editor. Zoom in so you can see what I'm doing. And let's add a bunch of serialized fields. We're going to want a couple of sprites. I'm going to change sprites depending on whether we're thrusting or not. There's a subtle difference I noticed in the ship sprites that I think will give a little extra visual cue when the engines are turned on. And let's see, I want to add a game object for that engine thrust so we can turn it on and off. I want to add an audio clip. Actually, I want to add 2 audio clips. And they're going to be a fire sound for when we shoot our weapons and an explosion sound. I might also want to add a smart bomb sound or a hyperspace sound, but we'll get to that later. We need a sprite renderer. I'm just going to call it renderer. And I want a couple of variables for our vertical and horizontal speed. So I'll just call this speed. And I'm going to give it a value of 5. And then a vertical speed. Vertical speed. I'm going to give it a much higher value because the way I'm going to do this, the movement for the ship, I'm really scrolling the background and I'm just scrolling the texture offset. And a speed of 5 is pretty fast. But for the ship's vertical speed, I'm going to be setting its velocity on the y-axis, and that needs to be a much higher number. Okay. I want a vector 2 for our legal altitude. So basically, I want to limit how high and how low the ship can move. And I want, when I was prototyping, I came up with some values that look pretty good, and I will go with them. All right, I want to expose that speed variable publicly. So I'm going to say public float speed, and I'm just going to expose that serialized field. And public properties should be, and variables should be what's called Pascal case. So a capital first letter and then lowercase. If there's multiple words like this, you want to use camel case. Well, Pascal case again. So capital and then a camel hump in the middle. For private variables, you want underscore lowercase, or actually underscore camel case. So if this was 2 words like engine thrust, it would look like that. And then variables inside a function with local scope are just all camel case without the underscore. Just a little bit of naming convention stuff for you there. Let's add some private variables. I want our user input. I want to cache our transform, and this is for performance reasons. There's a little bit of overhead. Man, there's a little bit of overhead when you reference the transform directly on the game object. So it's usually more efficient to go ahead and cache it here. And then we're going to create a rigid body 2D and grab that off of our, I'm going to actually just call that rigid body. I'm going to grab that off of our component. We want a variable to tell us whether or not we are thrusting. And we want to know our current direction. That'll be -1 or 1, depending on whether we're going left or right. And then our move input and our thrust input. Those are going to be coming to us as vector 2s. And then I want the index into our sprites array. And I will create a couple of variables here. Is thrusting. This is just going to be a little helper property that's going to tell us whether our thrust input.y is greater than 0. That's a vector 2, and I believe that the gamepad is going to be giving it to us on the y-axis, and the same thing with the keyboard mapping. I'm going to call this is thrusting. And we want a boolean to tell us if up is pressed. And that's true if move input is greater than 0. Move input y is greater than 0. All right, and the same thing for down. And we'll get, I've already exposed our direction, haven't I? No. So let's say public float direction. So I'm putting our publicly accessible properties at the top of the file. And now we want to create an awake method. So in awake, we're going to get our user input. Actually, we're going to cache our transform. And our rigid body. And now to get our user input, we're not going to call getComponent. We're going to call find object of type user input, just like we did on the title screen. And that should be good enough for awake. Now let's subscribe to some events. So in onEnable, user input.onMoveReceived, we're going to handle onMove. User input dot on thrust received, we're going to handle on thrust. User input on flip direction pressed, we are going to handle on flip direction. And if you're noticing that none of these things exist and we're getting errors, that's exactly right. We're going to create those functions after we get finished declaring them all here. On fire pressed, handle on fire. And then we're going to initialize our direction to 1. Now let's unsubscribe from all these events and on disable. It's always a good practice. And let's do on fire first. So in on fire, all I'm going to do currently is debug out a log statement. Fire pressed. And let's handle on flip direction. I gotta just remember to hit enter. All right. Handle on flip direction. We're going to change our rotation. So we're going to say rotation. We're going to get our current rotation, actually our local rotation. And we're going to take its Y value. And we're going to set it, depending on which direction we're currently facing. If we're currently facing our normal direction, so our Y rotation will be 0, then we will flip around 180 degrees Otherwise, if we're not 0, we're going to set it to 0. So this is what's called a ternary operator. So this is a comparison statement. We're saying if this condition is true, use this value. Otherwise, use this value. So it's just a shorthand way of writing if this, then this, else that. So hopefully that makes sense. We're going to set our local rotation to equal that new rotation value. And we're going to toggle our direction. Okay, and that direction variable is used to determine how we scroll the background when we're thrusting. All right, so that's on fire. Let's handle on thrust. So all we're going to do in here is set thrust input to be value.get. Oh, I did not call that value. So we want to say value.get, and we want to get a vector 2. And that's all we're doing in handle on thrust. I might also want to call a function to toggle that thrusting game object on our component. And I'll also call that from update. And actually, I'll probably call it from on enable. All right, so that's on thrust. The last one here is on move. And we're going to do something similar to what we did for thrust. We're going to say move input equals, got to give this a value of value. So this will be value.get vector 2. So that will handle that. All right, let's go look at our functions here. I'm going to add a function here. I'm going to call it update engine thruster. And I will select all this. Actually, let me just backspace out of that. Shift delete. And I will pick all these lines and Control Alt Shift down arrow. And I'm going to move that all the way down to the bottom of the file. Okay. And so what do I want to do in update engine thruster? I basically want to say that the engine thrust set active is thrusting. So this value is going to be set based on whether or not our thrust input.y is greater than 0. And so in on enable, we're calling that. So it should initially be turned off, I would think, the first time we come in here, but this will turn it on if thrusting is enabled. And now in handle on thrust, I'm going to do the same thing. I'm going to say update engine thruster. So if we start thrusting or stop thrusting, we should turn it on and off. I think we might have enough code to just test turning the thrusters on and off at the very least. Let's go back into Unity. Let that think. Let me look at our script here. We need to apply some things. So engine thrust will go there. We want to add our sounds. So we're going to want a fire sound and an explosion sound. I'm pretty sure the explosion sound was this one. Yeah, so I will take this distant explosion and assign it there. Our renderer will just be our sprite renderer. These default values look fine. We just need a fire sound, which we will assign when we actually start shooting weapons. We'll save that for later. Let's turn this to play maximized and hit play. So there's our ship. If I hit thrust, we get an error. An invalid operation exception is saying it cannot read a vector 2. So there must be something in the way I mapped that particular input value that it says it can't read a vector 2. So let's go revisit our player input. So as you recall, we put that in the input system folder. And here is our thrust. And here's the problem. We defined it as a button. I think what I want to do is I actually want to change that. I want that to be a value, and I want it to be a vector 2. So I think that that should work. And I'm also going to want to modify the way the keyboard control works because it's currently not correct. I'm going to delete this, and I'm going to add a binding with one modifier. So this is going to be a composite control, and I'm just going to call this keyboard. And we're going to have this guy is going to be thrust will be in, and that's up. And if I go back up to here, the composite type should be a 2D vector. And I'm just going to get rid of the the left and the right from that. And then this doesn't really need to be bound to anything because we're not going to have a thrust left or down. I'm basically just going to use the up value, but I'll go ahead and give it a binding just for the heck of it. I'm going to call it B since it's just on the other side of N. But this will never get used. So now the keyboard and the gamepad should both give us a vector 2, and the value we care about is up and down, so that's going to be the y-axis. So we'll close this, clear out this error, run again, and I'll take my stick and see if I can't get this thing to display the thrusting. And I got an error again. And so actually the error is pretty clear here. I'm pretty sure when I mapped that control, I mapped it to right stick right, and I just want it to be right stick. So right is just a single value, and I'm trying to read it as a vector 2. So let's go back into this, go into our thrust, and I'm going to rebind this. I'm going to say gamepad right stick. And I think that may fix it for us. Just hit play. Hit that right stick, and there our thrust turns on. And if I hit the N key, the thrust turns on. But I'm not really hearing our thrust sound. So let's play this again, but I'm going to play this focused. There's the audio source. He's got his audio clip. The volume is set pretty low, but let's just see if that is set to loop. Let's hit play and hit thrust again and see what happens. Let's try turning the volume up. I wonder if I play my title screen, if I'm getting any volume. Let's go to the scenes, title scene, hit play. So there's no audio mixer groups. That should be fine. Play on awake. There we go. Okay, so I need to fix that setting. So go back into our main scene, open our PlayerShip, expand it out, pick the engine thrust. We want this to play on awake. Hit play. Okay, so hitting thrust shows our particles and plays the sound. We also want to change the sprite when we're thrusting, but we currently only have the one sprite on our ship. So if we look at our ship here, there's a list of sprites, but it's empty. So if we go into our art folder, and I'm going to expand this out a little bit and expand that up. Scroll down and so we can see our ships. There's a subtle difference between this ship and this ship. And I want to switch to this one when we are thrusting. So if I go back to the player ship, we have our sprites. This will be sprite 1. And this will be sprite 2. Okay. So we'll go back into our PlayerShip script. And we will edit that code to make it display the correct sprite. So we have our sprite index, as you recall. It's going to default to 0. And where we are toggling the thrust or handling, let's see, update engine thruster. This is where we're going to want to change our sprite. So we will say renderer dot sprite equals is thrusting sprites 1. Actually, what we're going to do is we're going to set that variable. We will say sprite equals is thrusting 1, otherwise 0. And then we will say renderer sprite equals sprites sprite. Now that should toggle our sprite to the correct one if we are thrusting. And it definitely is. It's subtle, but it gives a little bit of extra feedback to the player. I think that's nice. Expand this back out a little bit. And I think the next thing we want to do is flip our direction. So let's go back into the player script. And down here, handle flip direction. It should be happening. Let's just give that a test. I believe the flip direction button on the gamepad is to push down the right stick. And when you look at that, and on the keyboard, it's comma. All right, so I can engage the thruster. I can change direction. But I cannot yet move up and down. So the next thing to do is implement moving up and down. Okay, now that we got our ship flipping directions, let's get them moving up and down. Go into our PlayerShip script. And we're going to create a new method here called fixed update. This is another callback that Unity will call. Fixed update. So in here, we're going to calculate our velocity. It's going to start out at 0. So velocity equals vector2.0. That is a constant whose value is 0, 0. And now we're going to check and see if we are thrusting. So we will say if up pressed, and if you remember, we had our legal altitude variable that we defined at the top of this that's going to determine how high and how low the ship can move. So we're going to say if our transform dot position dot y is less than our legal altitude dot y, then we will say velocity dot y equals our vertical speed times time dot fixed delta time. So fixed update is called a fixed number of times. It's dependent on the frame. It's independent of the frame, so it's called a fixed number of times. And this is a typical place where we want to do physics-based calculations. So in this case, we're adjusting the velocity of our rigid body, and we want to do that in fixed update. So we're going to do an else statement here. We're going to say else if down is pressed and our position dot y is greater than our legal altitude dot x. So that legal altitude is a vector 2, where we have our minimum altitude and maximum altitude. And so we're basically saying as long as we're above the minimum altitude, then we're going to set our velocity to basically be the negative value of this. So we're going to say velocity dot y equals our vertical speed times time dot fixed delta time times -1. And after we've calculated our velocity, which may be 0, we will say rigid body dot velocity equals velocity. So if we jump back into Unity, let Unity recompile that script, hit play, and I'm going to grab my little gamepad here. If I move the left stick up, he moves up. If I move him down, he moves down, and he's clamped to those positions. So I can flip directions. I can engage the thruster, and I can move up and down. So that's all pretty boring. Let's see if we can't get him flying left and right. And to do that, we're actually going to be scrolling the background. And before I get into the background code, I want to create a new class that's going to be called a game manager. So I'm going to create a new empty game object up here and call that -- managers -- and I'll move it up under system, not a child of system, but just below system. And I'm going to create a new empty game object, and I'm going to call this game manager. And I'm going to go into our scripts managers folder, and I'm going to create a new C# script and call it game manager. I'm going to select our game manager game object, let Unity recompile that script, and I'm going to drag that script onto that game manager object. We will double click to open that up in the editor, zoom in here. One thing I'm going to do is we're going to have a reference to our PlayerShip. And I think instead of doing this where I have a backing variable and then I expose it, I'm just going to make this a property. I'm going to give it a public getter and a private setter, so it can only be set in here. So this needs to be public. Okay, so we have a public PlayerShip, which can be retrieved from any outside class, but can only be assigned in here. And I'm going to add a serialized field, PlayerShip. Actually, this is just going to be a game object. And this is going to be our PlayerShip prefab. And we're going to use that to instantiate a PlayerShip. going to create a method here called start game. And all we're going to do in here is say PlayerShip. Actually, we now have PlayerShip equals instantiate PlayerShip prefab dot get component PlayerShip. Now it's complaining because it thinks I'm trying to assign. Oh, it's just misnamed. Okay. All right. So we are instantiating our PlayerShip and assigning it to our public PlayerShip property here. I'm actually going to give it a name too. I'm going to say that PlayerShip dot name equals PlayerShip. And the reason I'm doing that is because if I just instantiate it as a prefab, it's going to call it PlayerShip and then in parentheses clone, and I just want it to be called PlayerShip. It doesn't really matter, but that's what we need. And the reason I'm putting this in the game manager is we're going to be able to call start game, and I'm actually probably going to extract this into another method called spawn player. But we're going to be spawning the PlayerShip at different points during the game. He's not just going to be added to the scene in design mode and then always be there. And the other thing is we need to be able to get access to our PlayerShip because there's properties on it we need to access in order to scroll the background. We need to know if the PlayerShip is thrusting. We need to know what his speed is, his horizontal speed, and all that is available from the PlayerShip, which we can now get from the game manager. So let's go back into Unity. Let that recompile. And under our Defender folder, we want to create a new folder and call it Prefabs. And we are going to drag this PlayerShip into there as a prefab. And then I'm going to delete it from the scene. We're going to go into our game manager and we're going to assign that prefab. So that's what it will use to spawn the PlayerShip. Let's just make sure that works. I do not see the ship. Because we never called that method. So for now, I'm just going to go into the game manager class and add an onEnable method. And I'm just going to call start game. We're going to refactor this later because we're going to have a instruction screen that pops up that shows how many points you get for killing the different enemies. And from there, we're going to call start game. And then we're going to have to be able to restart the game when the player's out of lives and they want to replay. So this will be good for now just to get the PlayerShip spawned. If we go back into Unity and hit play, we should see the PlayerShip. And there he is. Okay, so now we want to create an object for our background scroller. So we got our background mountains here, and he's got a sprite renderer. But we want to add a new C# script to him. So we'll go up to the root of our scripts folder here. We'll right-click, create C# script, and we will call this background scroller. And we will select our background mountains, let Unity recompile scripts. And we will drag that script onto our background mountains. Let's double click that to open it up. Zoom in. And let's implement that script. So we're going to need a renderer. So we'll have a serialized field, renderer. And we're going to need our user input. And we're going to want the game manager. And then we're going to add a method here, PlayerShip, expression body method. That will be game manager, PlayerShip. So we will get a reference to the ship from the game manager. Now in Awake, we're going to get our user input by calling find object of type user input. And we're going to get our game manager by calling find object of type game manager. And in late update, this is another Unity function. We'll hover over that. It says late update is called every frame if the behavior is enabled. And this is going to get called after update and after fixed update. So this is where we're going to just update our display based on what's happened to the units in the game. So get rid of this throw that we don't need. We want to see if we have a player ship. So if we have a player ship, actually I want to see if we don't have a player ship or we're not thrusting. So I'm going to need to add that property. Well, I guess I can, is that exposed from the player ship? It's not. So we're going to add this to our user input. User input.is thrusting. So if we're not thrusting or we don't have a player ship, let's just return. So I'm going to say create a get only property is thrusting. And then we're going to implement that in our user input class. So right here, public bool is thrusting. And that will be thrust. We're going to have to add thrust input. Thrust input dot y is greater than 0. So now we're going to create a field thrust input. So we got move input. This will be a vector 2 thrust input. And where we handle the thrust, I'm going to assign this to thrust input, and I'm going to get rid of this log statement. All right, that should do it. Now let's go to background scroller. So if we don't have any thrust or we don't have a player ship, we just return. Now we want to get our current texture offset from the renderer. And this is how we're going to scroll the background. We're going to take the render, material, get texture offset. And we're going to use the main text property from that. And Ryder is complaining and saying that this lookup is inefficient. The string-based lookup is inefficient. So what we can do is just say use cached property index. Now if we go look at the top of our file, you see Ryder has added the static read-only int main text and it's doing a shader.property.id main text. I think I don't want that T there though. Yeah, it's not text, it's text. And I'm going to rename this. I'm going to do Control-RR and just get rid of that T. If I scroll down here, it should have changed it here. Okay. So we're getting our texture offset by looking it up from the texture. We want to calculate how much we want to scroll the background. So we're going to say distance to scroll. It's going to be time.delta-time times PlayerShip.horizontal speed. Well, I guess I just called it speed. Times the PlayerShip's direction. So if he's going right, it's going to be positive. If he's going left, it's going to be negative. Now we're going to calculate a new offset for our texture. So new offset equals current texture offset plus vector2.right times distance to scroll. And then we're going to tell the renderer material to set the texture offset to be for main text to be our new offset. And that should scroll the background based on our thrust speed. So if I go back into Unity, let that recompile. I hit play. Our ship should spawn. And I have an all reference exception because I didn't assign our renderer. So let's go into our background mountains. You see we need our renderer here. I'll just drag sprite renderer down into there. Hit play. There's our ship. So I actually am doing the opposite. I'm thrusting when I shouldn't be. But we see that the background is scrolling based on the direction that the ship is facing. We just need to make sure that we're handling the thrust state correctly. And so I'm pretty sure I know what the issue is. If I go into our background mountains script, or background scroller, let me get rid of this. And we go down to our late update. This should be not. We want to say if we're not thrusting, return. So even though we weren't thrusting, we thought we were. But I also think that my logic for is thrusting is wrong. The more I think about it, I think it should be the x-axis that we're looking at. And I don't want to just check to see if it's greater than 0. I think I just want to say if it's equal to 1. We'll try that. And also I can go into, what is it complaining about here? Possible loss while rounding. So what I could do here is I could say mathf.approximately 1. And this will compare if our thrust x is approximately 1, which is close enough for floating point comparison. Now let's go into our PlayerShip, or let's see, yeah, PlayerShip. It does not need its own is thrusting. So I'm going to get rid of this. And I really don't need our own up pressed and down pressed either, because I can get that from the user input. So we should see a bunch of errors now. So I'm going to say user input up pressed, user input down pressed, user input is thrusting, and user input that is thrusting. So let's go back out into Unity and give this all a test. And I want to play this maximized. So there's our ship. We're not thrusting, and we're still not thrusting. Oh, there we go. It seems to be a little iffy. So I might have to do like a... My gamepad stick is a little finicky. It has to be just right vertically to be counting on the x-axis. Let's try it from the keyboard. I will use the W and S, N key, and I'm not getting the thrust from the keyboard input. So I'm going to have to debug and see what value I'm getting for thrust from the keyboard. So I'm going to go into our input system in our user input, and I'm going to scroll down to on thrust. I'm going to put a breakpoint here. I'm going to attach to the Unity editor. Looks like I'm already attached to the Unity editor. I'm going to go into Unity and hit play. And then I'm going to hit the N key and see if it doesn't trigger our thrust event. And it does, and I've got a breakpoint. So if I open that up, let's get our thrust input value and look at it. It's 0, 1, so it's the y-axis. It's very interesting. So it's a y-axis for the keyboard. Let me use the stick and take a look at the value that I get. So this is an exponent. It looks like the main value is on the x-axis. So I think it's the way I have this input defined in our input manager. I'll let that fly. Detach from the Unity editor. Go back into Unity and stop playing. And go take a look at our input system and look at thrust, keyboard. So this is up. I want this to be right and left, not up and down. So I'm going to say right, left. Hit play. Hit our N key. Flip directions, move up, move down. Okay, so keyboard input works and gamepad input works. By the way, if you're interested in the controller that I'm using, it's just this cheap little $20 controller that I got from Amazon. I'll put a link in the description. I'm not sure I'd recommend it for serious gameplay, but I just wanted something inexpensive that I could use to test with the Unity input controller. So you can see I've got this wired up to the new Unity input system, and it is working for the most part. So there you go. Well, I think I'm going to call that a wrap for this video. It's gotten a lot longer than I intended. I'll try and streamline the videos in the future to go a little bit smoother. In the meantime, if you found this useful, do me a favor and click the like and subscribe button. It really does help me to grow my channel. And if you have any questions about anything I covered or any suggestions, anything you'd like to see, drop a comment below and I'll do my best to respond to it as soon as I can. Thanks so much for watching and good luck on your game development journey.